So, just remind me, we are looking at integration. Now, if you remember, integration is the reverse of
differentiation.
Is the reverse of differentiation. Okay. So, what is differentiation to do with? So, if I'm asking you to differentiate something, what am I asking you to do?
Subtract one and
Not yet. So, I'm not asking for the rule. What is differentiation?
find the gradient.
Yep, absolutely. It's to do with finding the gradient of a function. So the gradient, remember, another word for that is rate of change. How something is changing. Okay. What is integration to do with? Can anybody remember? Finding area. Good. Okay, so two completely separate ideas to do with curves. One, differentiation, is to do with finding the gradient, finding how quickly a function is changing at any particular point. Okay. Integration is to do with finding the area underneath that curve. All right. So, Ahmed, you can now answer my question. How do we differentiate? So if we take a function, how do we differentiate that function? What do we do first? Sorry?
Subtracting one from the power.
Differentiation.
Or differentiation. We multiply the power by the coefficient.
Good.
Then subtract one from the power.
Perfect. Okay, so a two-step process. So to differentiate, you would multiply by the power and then reduce the power by 1. Okay? Now, if we wanted to go back the other way, because you remember integration and differentiation, they undo each other, like multiplication and division, or addition and subtraction. Okay? Fundamental theorem of calculus tells us that they are inverse of each other, so we just need to go back the other way. So what's the first thing that we're going to do to undo this?
Add the power.
Yeah.
To the power.
So add 1 to the power. Okay, then what's the second thing we're going to do? Good. So if you're ever not sure about integration, differentiation, you get confused between the two, just remember differentiation, we're experts with that now, okay? And then just go back the other way. Just go back the other way. So this way is differentiating, this way is integrating. Okay? Right, so let's have a go at this one then. So we have the integral of x squared plus 3x with respect to x. Now, because there's no limits here, because there's no values that we're going to stick in, what type of integral do we call this? Perfect. We call it an indefinite integral. But the process is still exactly the same, okay? So let's have a look. We just basically treat each thing separately. So first of all, we need to add 1 to the power, then we need to divide by that power. So x squared, if we add 1 to the power, what do we get? X cubed, perfect, then we divide by that power. Make sense? Yep. Okay, then we look at 3x, okay? So what's the first thing we need to do?
3 over 2x squared.
Perfect, so we need to add 1 to the power to become x squared, then divide by that new power, okay? Am I finished? Good, I need to plus c. Why do I need to plus c?
There could be a number that has been deleted by the differentiation.
Exactly, because if you think about this, this is just the reverse of differentiation, which means that if I differentiate this, I should get back to this, okay? Well, if I differentiate that, I get x squared. If I differentiate that, I get 3x. But of course, you're absolutely right, Ahmed, you could have had a number sitting here, okay? So if you think about it, when you differentiate just a number, a constant, that should differentiate to be 0, okay? So you just add that constant of integration there to allow for that. Does that make sense? Okay. Do I have to do any more than this at this stage? Nope, because it's an indefinite integral. I don't need to stick numbers in. Okay? Good. All right then. What am I going to do with this one? Can I integrate it straight off the bat? No, why not?
We need to get rid of the x division.
Yeah, exactly. It's exactly the same thing with differentiation. I need to write it something like this. Okay, I need to write it something times x to the power of something. Because I've got fractions and things going on, I can't do it at the moment. But that's okay, because I know my laws of indices. So, okay, what could I do here?
We can just take the x for this one, and so it's x over power 4 over x plus 5x power 7 over x.
Absolutely. So each term on the numerator gets divided by the denominator. So in other words, I get x to the power 4 divided by x, which is, Megan?
X.
What's x to the power 4 divided by x? Good? Yeah, x cubed. Excellent. And then what about 5x to the power 7 divided by x? Good. 5x to the power 6. Excellent. Well done. Okay. Are you happy now? This is in a form we can integrate. Okay. So Megan, keep going. What would this thing be integrated?
X to the power 4
Yeah.
over 4
Perfect.
plus 5x to the power of 7 over 7
Perfect.
plus c.
Excellent. Well done. Good. You happy? Good. All right then. What about this one? Batacam. What are we going to do here? Don't tell me the answer. Tell me how we do it. Absolutely right. Yeah, because we've got products going on, we need to expand this out. Okay. So x squared plus x dx. Okay, and then can you do the integration for me as well? Absolutely right. Perfect. Okay. Good. All right. Now question four now has limits going on. In other words, we want to find the area between 1 and 2. Okay. All of these things, so all of the things in red, would be my area function. In other words, it would give me the area up until whatever point I asked for. Okay, so these are my area functions. Just like with differentiation, we had a gradient function. This is now my area function. Okay, but here I actually have two limits. I actually have two things that I want to find it between. So what type of integral is this? Perfect, definite integral. Okay, fine. So what do we have to do here? Because clearly this is an x to the power of something. Perfect. So this would be the integral between 1 and 2 of x to the power of a half plus 7. Okay? Okay. So let's come up with our gradient function. So what do we get? Good, because I need to divide by what 3 over 2, which is the same as doing multiplying by 3 over 2. Plus 7x. Excellent. Okay. Now, because I'm going to stick values in, I'm going to put my square brackets in. And I'm going to write 1 and 2 here. Now, here I'm not finished, am I? Because I actually have values to stick in now. So what value am I going to stick in first?
2.
Good. It's going to be 2 to the power of 3 over 2. Plus 7, 2, plus c. Okay. And then I'm going to stick in 1, but what am I going to do to these two things? I'm going to subtract them. Okay. All right. So, stick it in a calculator. What do we get?
15.89.
Okay. And clearly the c's will cancel anyway, so you don't need to worry about the c's now.
And 23 over 3.
Is that the one on the right?
7.66, yeah.
Okay. Just give me the final answer. What do we get?
Minus 7.66 for the 1. The 2 was correct.
Okay. So this one here.
It's 15.89.
Okay.
Minus 7.66. 67.
It's 15 minus 7.67. Okay. What do we get?
1 second.
Actually, I would encourage you, if you're working this out on a calculator, write down both separately as well. Break it down.
Oh yeah, that's what I did.
Excellent. Good. Go on then.
8.22.
8.22. Is that your final answer? So you're basically saying that the area underneath this curve here between 1 and 2 is going to be 8.22. Does that make sense? Good. Excellent. Now, are you happy? Question 5 looks worse. It looks worse. It looks worse than everything we did over here and everything we did in question 4. But are you happy it's not?
It's the same thing as question 4.
Exactly. It's exactly the same thing as question 4. In fact, it's easier than question 4 because I think this function is slightly easier. Yeah? It's just different limits. So if I want to find the area, I just need to integrate. So I'm trying to integrate. What are my limits?
0 and 1.
0 and 1. What's my function?
3x squared plus 7x plus 5. Yes.
Good. That dx, remember, just means a really, really small change in the x direction. It's just basically adding together areas of lowest nodes of rectangles between 0 and 1. Okay, that's where it comes from. Okay, good. So let me just go for it. Okay, so what would the area function be?
X power 3 plus 7 over 2x squared plus 5x.
Good. Plus c. Okay, between 0 and 1. By the way, just pause for a second. Have a look at question 4, okay, and compare it to everything we did on this side. Are you happy with the indefinite integrals? We needed to put that plus c. We needed to put that plus c, yeah? Because it could be any number, which when we differentiate it would take us back to 0. So we needed that plus c. However, with definite integrals, are you happy that that plus c will just get cancelled out when we stick the limits in anyway?
Because plus and minus c.
Exactly. So if you wanted to, with the definite integrals, to leave that plus c off, I don't mind. Okay, I don't mind. Right? But if you're not sure and you're like, I'm not sure when I should, whether I shouldn't, just put the plus c there. Okay, it'll end up cancelling anyway later. Okay, good. So now we stick the 1 in, and then we stick the 0 in. So let's have a look. Could probably do this in our head.
It's 19.
Is it? Okay. Plus 5 times 1 plus c, and then minus, well, that's going to be all 0, so 0 cubed, plus 7 over 2 times 0 squared.
That one is 0.
Yeah. Okay, so obviously the c's will cancel, so yeah, you just get 1 plus 7 over 2 plus 5, which is
19 over 2.
19 over 2,
9.5.
or 9.5, that's fine. Happy?